Welcome to AP Calculus, Lesson 1-1, Limits to a Point on a Graph. It's an easy lesson, and they have the door locked so they can't even be like, be quiet. All right, so limit notation. What does it mean to have a left limit, a right limit, and a limit from both sides? This is where you're finally doing some writing, so here we go. So a left limit, you say the limit, so that's how you just write a limit. LIM is shorthand for limit. And as your variable approaches some point, so I'm going to say my variable is x, that's what our variable is usually, and approaches. Approaches is an arrow. So I read this, the limit as x approaches some point, so I'm going to say c. c is like 2. So as I get closer and closer to 2. But how do I say from the left? Here's the key thing. From the left, I do c to the power of negative, I guess. That's how you could see it. So the limit as x approaches c from the left of this function f of x. That is everything that you need to write for a left limit. Let's do a right limit. And my handwriting will get progressively better. I know that it's super sloppy from the summer of not doing anything. The right limit is going to be limit as x approaches c. Something's going to be changed here of our function f of x. Is there a quiet raised hand, maybe Claire, that knows the limit from the right-hand side? Let's give it a Geo, yeah.
So it's going to be limit x, but with like the arrow flip on.
The arrow flipped? Oh, that's a good idea. It's actually the same arrow, Claire.
You put a negative thing on the other side.
It's a plus side. Yeah. So if it's negative, it's from the left. If it's a positive, it's from the right. And I'll talk about what those mean in a sec. I just want you to get your head around the negative means left, plus means right. And both sides is the trickiest of all of them. It's the most commonly forgot. Whenever you see the negative, you always think, oh yeah, that's from the left. Whenever you see from the positive, you say, oh yeah, that's from the right. But the both sides is the hardest to remember. It is the limit as x approaches c from, and then f of x.
That's it?
Want to repeat that?
So what? So it's the same thing, but what's going to go here?
A plus and a negative.
That would be really, like, that would make sense, right?
Not
Okay.
That's why it's the hardest to remember, because if there's nothing there, you always have to assume both, left and right. Not just going left, not just going right, both. Okay, so what does that even mean now? Let's talk about what these things mean. So I rewrote them. That's what they look like when they're typed up, 1, 2, and 3. I want you to find what those limits are. And limits are really asking, what is your height approaching? What is your height approaching? Sometimes you actually know what it is at that point, but I just care what happens right before that point. My calculus teacher had this really interesting way of saying it. He had a dog that he would like to really mess with in his mornings on his walk to school. He would get really, really close to the dog's fence, but he would never touch the fence because it was an electric fence. But he would mess with the dog. He'd get really, really close to the dog's fence. The dog would bark and bark and bark, and he hated this dog, so he loved it. Get really, really close to the fence, but he would never touch the fence because he'd be shocked.
I mean, why wouldn't the fence shock him from just being close? Like, that's the
In my head. But he got really, really close without touching. That's what a limit is. You're getting really, really close to that electric fence without getting shocked. I don't care what happens at that point of being shocked. I care what happens when I get really, really close to that point. And from what side. So when I'm talking about x approaches c, well, there's c. So as I get closer and closer from the left-hand side, so I'm getting closer and closer and closer to c, what is happening with my height? Well, the height is going like this and this, and as I approach c, I'm getting closer and closer to what height? 5. There it is. The answer is 5. Here's our answer. C, and you can even do like a little dotted line if you want. I bet I have a way to do this a little bit more officially, but there's my dotted line. As I get closer and closer from the left, this arrow represents I'm getting closer and closer to a height of 5. And then I need someone else to read this. How do I read this? I don't say limit as x approaches c positive f of x. It's a little bit more complex than that. You have to use the word right or left. Can someone read it? Stago, you haven't participated yet. You got this. You got this.
I'll try. So as x approaches c from the right.
There it is, from the right of our f of x. Yeah. So the limit as x approaches c from the right of our function f of x, and this is f of x. Is there a quiet raised hand for what the answer is? Quiet raise hand. Quiet raise hand. Stego, come on, you got this. What is the height approaching when I get closer and closer to C? I'll even give you a hint. So if I'm coming from the right, I'm now coming from this side. I'm coming from this side closer and closer and closer. But as I get closer and closer to C, without actually touching it, what is the height? 5. There it is. Good job, Stego. All right, and Claire, you get this one. How do I read number 3?
The limit of x approaching c for both sides.
There it is. And what is that, Claire? 5. Yeah, I mean, if the left hand limit and the right hand limit are the same, obviously the double-sided limit is the same as well. Okay, so this is the hard part. Can you draw a graph where the left and right limits are not the same? And this is going to be difficult, and I don't expect everyone to be able to do it, but it's just playing with math. I love this idea of being able to play and see, is it possible to break things? I want to break some things. Can I make the left-hand limit and the right-hand limit not the same?
So
Draw a graph.
I'm guessing that's not possible.
It is possible.
It is possible.
And don't flip over to the back because that's the answer. That's one of many, many thousands of millions of infinite possibilities. No, Gio!
I didn't see it.
Try to draw a graph where the left-hand limit and right-hand limit are not the same at the same point. It can't just be A and B. Obviously, they're different limits. At the same point, where are they not the same? Try to draw a graph. I'll give you guys 2 minutes.
It's so weird being in this class because I like just to but,
I mean,
Arrow's like ready to jump up here.
well, no, maybe I'll actually learn
Hey,
stuff.
Arrow, you want to give us a hint?
Wow.
So it's this fun idea of tackling this problem. It's hard, but you guys, you're imaginative.
This is oh.
I don't know how to do this.
It's okay. Just think about it.
I'm thinking about it.
Yeah, see.
You know, actually, I was really stressing out about the homework. Like, I almost passed out at work. Like, I'm not even joking. It was really bad.
Okay, so I will draw 3. I'll give you 3 examples. Are you ready for the first one?
Yes, sir.
So, and I'll even do it on Desmos if you want.
Fancy.
I'm a fancy pants. Yeah, let's do this. Let's do a simple function y equals 1 divided by x. It's a little bit hard to see. Let's do projector mode. See this line right here? I want the limit as x approaches 0. As I approach 0, so I'm getting closer and closer to 0, from the left-hand side, I go to negative infinity. I'm just going down forever. You actually write that as negative infinity. So as I go left, I go to negative infinity. As I go right, I go to positive infinity. So that is one example where I go to 0, and the left and the right are not the same. Left is negative infinity, right is positive infinity. They're going to different spots. Kind of weird. I'll draw another one. A little bit harder to do with Desmos, that's the reason. And it's very simple. Let's do any random line, giant hole, and another random line that goes off like this.
Okay.
And you might be saying, well, that's cheating. You broke it. Well, I'm allowed to break things. That's the whole point, right? So this is saying, as I go to the left, let's say our limit is to negative 2. As I go to the left, getting closer and closer to negative 2, I get a height of, but if I go to the right, I get closer and closer to.
Okay, I thought you had to do the same line.
Ah, okay, so you're thinking about what's called continuous. Continuous means I have to hold my pencil without picking it up.
Yeah, I thought.
And we'll play with that idea a little bit later, but yeah, so this is discontinuous. You wanted it to be continuous, but in calculus we're allowed to be discontinuous. We're allowed to play with things a little bit more. All right, so let's give us another example. What would be another example where the left and the right are not the same? I mean, it's basically this same idea where they just don't match up. I mean, you could do something that comes down here, open dot, and then another open dot that comes up like that. It doesn't really matter how the lines are arranged as long as the heights are different at the point that you're taking the limit. Let's go to the back, because that is one possibility. It's a little bit fancier because it's typed up, obviously. This is an example where the one-sided limits are not the same. Let's try to play with it again. It's the same 3 questions. As I get closer and closer to this -1, as x gets closer to -1, what is the height? I want you all to think about 1, 2, and 3 by yourselves. And maybe if you're really confident, write down your answers. I'll give you 30 seconds. Think about these questions.
Okay, I'm not sure about the third one.
So I don't like him.
You got it. The first one's correct.
Oh wow.
Wait,
going to give you guys still a lot of time. We have 5 more seconds.
That's a
That's
lot.
a lot of time.
That's so much time. It's just-
All right, so Stego, tell us what number 1 was and why.
Oh, 2.
2. Why is it 2?
Is that your height?
That's our height. As I approach 1 from the left-hand side here, my height is 2. All right, Claire, talk to us about why number 2 is what?
Is -1 because as it reaches -1 on the x-axis, it goes to -1 on the y.
Exactly, yeah, it goes to a height of -1. And then Gio, can you repeat your awesome question?
What did I ask?
What happened? Like,
Yeah, like I don't know.
yeah,
Do like I subtract? I don't know.
what happens? Like, when I go from the left and the right, so the general rule of thumb is if the left and the right don't match up, there's no answer.
Oh.
And the way that we say that in math is does not exist. The answer does not
For the
exist.
longest time, I thought you were just writing 1. Like, you messed that up. I don't know. I thought you'd put 0 and then changed your mind. And instead of making it 1, had written 1. Different thing.
Yeah, you're still learning as my TA. There it is. That's it. That's a lesson.
Okay. Cool.
Ah,
Okay, so the summary you're not going to do right now. That's something that I learned over the summer. And I'll talk about why in a sec. Let's end the video.